happens. I apologize for that. So we're going to refer to this as Z alpha over 2, which really is, this is where it should start making a little more sense. It's just Z sub 0.025. All right? That's all that it is. Now, if this is Z sub 0.025, then this is Z sub 0.025, except it's on the negative side. Remember, all of this is going to be on the standard normal curve. So this is 0 is going to live in the middle, in theory. All right? So this is negative Z sub 0.025. Okay? Now, the hard part here, remember, building a confidence interval, if I want a, oh, wait, let me do one more. Let's say that I wanted to do a 99% confidence interval. Why did I write an E? If I want to do a 99% confidence interval, CI. All right, now, same curve, because it's all going on our standard normal curve when everything's said and done. Only now, we got something living in here. Now remember, we're going to send everything onto our standard normal, so this is going to turn into a 0. Remember, standard normal is the link to all other normal curves. This normal curve is created by the sampling distribution created by all these p hats, right? Okay, now in this case, we carve out our 99%, right? So if this is 0.99 or 99%, then do you agree that the outside area is going to be 1%? So that is our alpha. We're going to call that alpha equals 1% or 0.01. But because this guy is split in half, these guys right here, alpha over 2 is going to be 0.005. And we refer to this boundary of the interval as, in this case, Z sub 0.005, and this guy right here as negative Z sub 0.005. Because if I add them together, I get 0.01, which is 1%. You could do the same thing for a let's see, think about this. So 98% CI. What we're interested in is that boundary area. That would lead us to 98% would if I have a 98% confidence interval, then my alpha, my missing part, is 2%, which is 0.02. So what I'm interested in is these boundary values, which in this case is going to be Z sub alpha over 2, which is Z sub 0.01. All right? Easy. Nothing to it. All right? Now, I'm going to do some actual mathematics with you guys, and we're going to prove this error thing. All right? I think you'll enjoy that. Remember, everything has to do with the normal curve. I got to get real. Get me on my black pen here. Everything has to do with the standard normal curve, which implies that Z is equal to X minus mu over sigma. Okay? Now you may say, wait, Ripley, I thought we had the central limit theorem thing going on here. So we divide by the square root of n. Well, let me show you here. Let me show you something here for just a second. Do you agree that p hat in the dog question is equal to X? If I let X equal the number of people that responded that they have a dog in their household, then p hat, the proportion, is going to be X divided by n. So really, this X and this X are kind of the same thing. This guy's just the number of people that responded, yeah, I got a dog in my house. All right? So doesn't that imply that X is equal to n p hat? Okay? Now, remember also this mu right here. All right? The actual mu is np. It's the true proportion times the number. That's going to be the average number. I mean, think about that. The true proportion is actually going to be the number divided by, or excuse me, mu, the mean number of people, divided by n. So I just basically did this trick twice. I know that mu is np, I know that x is np hat, and then I know that sigma is equal to the square root of npq. Now, that said, check this out. What we're going to do is, again, remember, I don't know what P is. We are going to end up building a confidence. We're going to build a 95% CI around, my pen's acting strangely, around P, the true population proportion. And that guy lives right here. Let me change colors. That guy lives right here. But we have to use these point estimates to do that. So really this sigma right here isn't NPQ. We need a sigma that is also a point estimate. So what it is it's N P hat Q hat. All right? Now, I'm going to use my very simple Z formula right here. And I'm simply going to plug all these things in. Now watch this. I'm going to get Z equals N P hat minus NP divided by the square root of N P hat Q hat. Okay? Now, I know that your textbook doesn't have this proof, but this is a college level stats course, and I really want you to think about what's going on here. And I'm not expecting that you'll get this right off the bat every single time, okay? Just on the first one. I've had this process takes a lot, okay? Now check this out. Remember, the point of interest is these Z alpha over 2's, okay? What I want to know is, because these produce the outer edges of my confidence interval, and the confidence interval is created by adding error. So I want to know where to end my confidence interval. So I'm trying to figure out what error is. Now, I'm going to do something here, and I'll explain it further in class if you don't get it. To be honest with you, you could live the rest of your life and just sort of memorize the formula that I'm going to give you without ever knowing why this proof works. But for those of you that are going to see this down the road, it's a really good lesson to watch. Again, I am interested not in Z, but in Z alpha over 2, because I'm going to build an error around P. And that error is built by Z alpha over 2. Remember, error gets me right up to the boundary of this thing. So if I take Z alpha over 2, I'm going to do a little puff of algebra here that I think that you'll like. I'm going to factor out an N, all right? And I'm going to get P hat minus P over root N P hat Q hat, okay? And then if you think about this, remember the square root of a product is the product of the square roots. So this N and this root N are going to turn into something special, which I'll show you here in just a sec. If I cross multiply and leave this P hat minus P thing going on, watch what happens. I end up with Z alpha halves times, now you can scream and yell at me if you need to, root P hat Q hat over root N. Now, hopefully you see where the root P hat Q hat came from, because remember, when I cross multiplied up, I went. If you think about this, when I cross multiply, what I end up with is, we'll just do this as side work over here, so I'm going to put it implies. I end up with root N over N, which is N to the 1/2 divided by N to the 1, which is 1 over root N. That's where that guy comes from. All right? Then this is equal to P hat minus P. All right? Now, here's the really cool part. And I'm going to do a little bit of tomfoolery here, mathematically speaking. This is the guy that I want. I'm trying to figure out what this truly is, or at least the interval that contains this. I'm going to add P over, and I'm going to subtract this across, because remember, I'm sorry, this is the greatest work in the whole world. Remember, my confidence interval around the true parameter is P hat plus the error. Whoops, let's try that again. I'm on the left-hand side, you dingus. P hat minus the error, and P hat plus the error, right? Well, watch what happens. Doesn't this turn into P equals P hat minus Z alpha over 2 times root P hat Q hat over N? Now, let me rewrite that. I'll rewrite that over here. So it said that P, give you guys a little more space, is equal to P hat, right? Minus Z alpha over 2 times the square root of P hat Q hat over N. Hey, guess what? Remember, if I'm building a confidence interval, I get P hat plus my error and P hat minus my error. Guess what that is? If that's P hat, what's that got to be? right? This is going to be my error. This guy right here is my error. Now you may say, wait, Ripley, this thing right here only built out the left-hand side. That'd be a heck of a good question. But remember where this came from. I've got my z alpha over 2, right, times root p hat q hat over n is equal to p hat minus p. And then I did my little algebraic tomfoolery. Well, watch. Remember, I end up with a plus and minus z alpha over 2. So remember, because that z alpha over 2 defines the boundary of the interval because of the way that it behaves on the normal curve. So what that tells me is, if I want to build out the other side, this guy right here, watch. Let's deal with the negative side and then do exactly the same trick. If I add p over here and I add this term over here, I end up with p equals, excuse me, p hat plus z alpha halves root p hat q hat over n. Hey, remember this guy's name? It's error. And guess what I just built? The right-hand side of my interval. That is so cool. Whoa, I don't know what's going on with my error. That to me is so cool. I think that's just something special. Excuse me. Let's build one of these guys, shall we? Let's have a little bit of fun. All right. Let us say that, well, let's you know what? Let's do it around my dog. That doesn't make any sense. We're going to build a confidence interval. Let's do it around my dog survey. All right, a confidence interval around, we want to go 95%. Confidence interval around true proportion of household, that's an O, of households owning a dog, or having a dog, owning a dog. That's how they say it back east. Sorry for those of you back east, but I have kin in New Jersey and they say dog. Okay, so think about this. What did we have? We said that N was 5,000, and the number of people that said that they owned a dog, and I think in the binomial case, the number of people that owned a dog was 4,000, right? Excuse me, which gave us a p hat. Really, the only reason I wrote this up is to show us that our p hat was 0.8. Okay? Now, remember this formula right here, after we build our confidence interval, this formula, well, let's actually build out the formula, shall we? The confidence interval, we're going to make this sucker big, is going to be p hat minus z alpha halves root p hat q hat over n, comma, p hat plus z alpha halves root p hat q hat over n. Okay, that's it. That's all we need. All right. However, let's not get crazy here for just a sec. I got p hat. I'm going to do q hat, which is 0.2. I got n. That's nice. I need z alpha over 2. So let's figure this out. Z alpha over 2. Well, okay. What does that tell me? That tells me that if I'm going to be 95%, if I'm going to create a 95% confidence interval, then that tells me that alpha is 0.05, right, or 5%. So alpha over 2 is going to be 0.025, which implies that z alpha over 2, that's this guy right here. Let's change my colors just to make sure everybody understands what they're looking at. This guy right here is going to be 0.025. Which implies that my z alpha over 2, well, I'm going to have to go to my handy dandy charts.